For question number 3, it says, explain mobilization, transport, and cellular uptake of fat from adipose tissue. So these are the initial steps of lipolysis, which is when we want to break down fuels in order to utilize them to supply the body with the energy that it needs. And so for the first step, mobilization, this is where we want to remove fatty acid chains from their glycerol backbones. And so mobilization is activated in 2 ways, through hormones such as epinephrine, norepinephrine, cortisol, and growth hormone, or through intracellular signals such as calcium, concentration of ATP, ADP, or AMP, and the AD to NADH ratio. And so with mobilization, what happens is we have a hormone in the blood, binds to its receptor. This signal is sent to activate adenylate cyclase in the adipose tissue, which goes on to tell ATP to convert to cyclic AMP, activates protein kinase A, and further goes to activate ATGL, HSL, and MAG. And these 3 work together to break down the perilipid layer, which is a protective layer around the triglyceride. So each of them breaks down one fatty acid chain. ATGL breaks down the first fatty acid chain, HSL breaks down the second, MAG breaks down the third. This leaves us with 3 free fatty acids plus 1 glycerol molecule. These molecules go from the adipose tissue and enter the blood. This glycerol is used for GNG, gluconeogenesis, or for shuttles. The free fatty acid then is going to go to the muscle, and that takes us to transport/cellular uptake, which is the second step of lipolysis. The goal of this is to move the free fatty acid in the blood to the muscle and then into the muscle. And so when this free fatty acid enters the blood, it is combined or bound to albumin, which is a blood protein that is produced by the liver, and it basically acts as a chaperone for the free fatty acid in the blood. When this albumin and free fatty acid are in the blood, we want to get it into the muscle in order to continue on with lipolysis. And how that happens is we have binding proteins. In this case, we have a fatty acid binding protein, plasma membrane, because we're in the sarcolemma. It comes and embeds itself into the sarcolemma, allowing this free fatty acid to enter into the cytosol or into the muscle cell. Another way we can have free fatty acids taken up into the muscle is through fat CD36, which is similar to GLUT4. And how fat CD36 embeds itself is through an increase in calcium, which we're exercising, doing muscle contractions. That activates CA-MKK, which then tells fat CD36 to embed itself. In a similar manner, when we have an increase in AMP, because we have a decrease in ATP, increase in ADP leads to increase in AMP, which activates AMPK. That also tells fat CD36 to go and embed itself into the sarcolemma of the muscle, allowing even more free fatty acids to enter into the cytosol. Once it's in the cytosol, we have another binding protein. We now have fatty acid binding protein in the cytosol, plus a free fatty acid. And so, how do any of these steps differ from lipolysis within the muscle? Mobilization will be the same. We want to activate these enzymes to go and break down these triglycerides. But once we have these 3 free fatty acids, we don't want to deliver them back to the blood to then go to the muscle. We can just leave them in the muscle. And so that means that we also don't need to go through, we need the beginning of mobilization, but we don't need those molecules to enter the blood. And so there we don't need to go through transport or cellular uptake because we're already in the muscle. And so 2 variables that help regulate mobilization include we have an increase in our exercise hormones such as epinephrine, norepinephrine, cortisol, and growth hormone. We're going to have an increase in lipolysis because we want to break down our fats in order to use them as fuel for our body. And when we have an increase in insulin, we have a decrease in lipolysis. When we release insulin, that's rest and digest. We want to store our fuels, and so that will lead to an increase in lipogenesis, but it will lead to a decrease in lipolysis because here we want to break down our fuels, not store them. And 2 variables that regulate transport and cellular uptake include that when we have an increase in training, we have an increase in the fatty acid binding proteins as well as fat CD36, which means that our body is more effective at bringing these free fatty acids from the blood and allowing them into the muscle and getting them into the muscle so we can utilize them and break them down to use them as energy. And also when we have a high fat diet, that also increases fatty acid binding proteins and fat CD36 because, again, our body is good at using what we give it. So when we have a high fat diet, our body becomes really good at utilizing these processes in order to get these free fatty acids from the blood into the muscle so we can utilize them for energy.